homologous series. Family of organic compounds, or a series, or a family, like you see the 12 of the families there, that appears to have a structural pattern. There is a regular pattern in which members, successive members, will appear to differ from the next member by a molecular formula of CH2, or just differs in relative molecular mass of 14. That is homologous series. Look at the 12 families. These are the common or the main families of organic compounds that has their members. In the family of alkanes, the commonest or simplest member of that alkane family is who? The simplest member of that is what? Methane. What is the general formula of alkane? Let me start. CnH2n plus 2. What is that of alkenes? CnH2n. We cannot have plus again here. Do you know why? Because already that family has carbon-carbon double what? Bond. That 2 you see there is 2 hydrogen. Is what? 2 what? Hydrogen atom. So alkenes are short 2 of hydrogen atom. That is why their general formula is what? CnH2n. And then the simplest member of that family is what? Who is the first member? Is it methane? Methane does not what? Exist. So the first member there is what? 18. For the next member we have CnH2n. Is it plus 2 or plus 3 or minus 2? Is what? Minus 2. These ones are still owing. That's minus 2, having triple bonds in their long chain. The simplest member, or the first member of that series is what? Family. Is what? Ethyne. There is no methane. Is what? Ethyne. For the next family, we have alkyhalides. Alky what? Halides. The general formula is what? CnH2n plus 1. And then what? Then what? X. What is X? Where X is what? Halogen. That S can be chlorine, fluorine, bromine, or iodine. The simplest member of the family is this member, which is what? Methyl. Methyl what? Methyl halides. Okay, let me choose one halide. Let me choose chlorine. So that will be what? Methyl what? Methyl what? Chloride. Are you there? Methyl chloride. This is methane. 1, 2, 3, 4. Like this. H, 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 H. Methane. But if I substitute and then replace with Cl. So what is this now? The CH3 is not methyl. Chlorine becomes what? IDE, ending it. Methyl chloride. Or chloromethane. Are you there? Not chloromethyl. It's chloromethane, or you call it what? Methyl chloride. So the functional group of the alkyhalides is the what? X. The next family is alcohol. They are what? CnH2n plus 1 again. And add to 8. Added to that plus 1 is what? O what? H. Simplest member is methyl alcohol. Methyl what? Methyl alcohol. Alcohol. Which you call methanol. You know about methanol? That is this. The next member is a canal, CnH2n plus 1. Functional group is what I'm going to add, which is CHO. Simplest member is ethanol. Ethanol. Next member is CnH2n plus 1 CO. Commonest member is propanone. Next member is CnH2n plus 1 COOH. Commonest member is ethanoic acid. Next member CnH2n plus 1 COOCN H2n plus 1. Commonest member is ethyl ethanoids. Oh, I will say explain all of this one by one. Next member is CnH2n plus 1 CONH2. Commonest member is propanamide. Then this one is CnH2n plus 1 NH2. This one is propylamine. The last one is CnH2n plus 1 OCN H2n plus 1. This one is dimethyl ether. Please copy all of this. I'll say explain it. Okay. Okay, let's look at this quickly. No, you're copying. I'm still writing on the board. Okay, fast, please. Characteristics or features. Characteristics or features. Of homologous series. Characteristics or features of homologous series. Number 1. On the board, I'm writing. On the board. I know when I will dictate. Anything you see me write on the board, that means you must pay attention. Is an exam focus. Why I want to write this on the board? Last JAMB, this question was asked. I mean, the first one I'm going to mention now. JAMB Can't play with it. Last 2 years, it still came out. Number 1. Members on the board. Members differs from the next by CH2 units. Members differs from the next by CH2 units, or differs in molar mass of what? 14.0 gram. When I say members differs from the next, please let's look at that number 1 there, alkane. Let's look at alkane as a typical example. The 2 members there is what? Methane, Abby? Methane and what? Ethane. And let me add the 3rd member there, which is what? Propane, isn't it? Okay. Molecular formula of this alkane, MF. Molecular formula of this is what? CH what? 4. Abby? Relative molecular mass of this one is what? 16. Do you know how we got that? That is the atomic mass of carbon 12. Then add its 4 to 8. That gives you 16. So molecular formula of ethane is what? C2H6. Abby? So the molar mass of this ethane is what here? 30. Are there? Like atomic mass 12 times 2, 24 plus 6. Are you with me? This man is what? C3 what? H8. What is the molar mass here? What's the molar mass here? 44. Have you seen what we mean now? This will also be for other members. I'll give you another member, another family member. Alkanol. Alkanol is same thing as what? Alcohol. Alcohols. Let's look at the 2 members in that family. Let's look at methanol, methanol, and what? Ethanol. Are you there? So formula of this is what? CH3OH. Formula here, C2H5OH. Molecular mass of methanol is what? Carbon is 12 plus 4. 12 plus 4. Do you know how we got 4 now? H4. Add 4 to 12. What do you have? You have what? 16 plus 16. So molar mass here is what? 32. We're finding molar mass of the ethanol. 24. 24 plus 6. 30. 30 plus 16. 46. Check the difference, what they differ in. Now, from the first one, the next member immediately after methane, not after methane, propane. After methane, the next member of that series is ethane. The difference in their molecular formula must be what? CH2. Or the difference in their molar mass must be what? 14. Same thing is also applicable here. Difference in the molecular formula here is still CH2, and also difference in the relative molecular mass is still what? 14. That is what? That means that these are members of the same family or the same homologue. I will mean the same homologue. For them to differ structurally by this CH2 unit, or for them to differ slightly in their relative molecular mass of what? 14. Okay. Number 2, please make sure you take this in down. It's very important. So if they ask you in exam, the next member or the second member of alkane is ethane, Abi. That means ethane will differ from the next, which is the 3rd member, by what? CH2, or differs in relative molecular mass of 14 grams. Number 2, I'll still write on the board. Number 2, members have the same members have the same general molecular formula. General molecular formula are the same for all members. I will still use this also as an example. All the members of alkane, from where we get this formula from, that determines that this is methane, or that dictates that this is methane, is from what? CnH2n plus what? 2. All members, they didn't end here. The member continues. They will all be derived from this formula. Are you with me? So members have the same general molecular formula. Even this, the general molecular formula of the alcohols is what? Is CnH2n plus 1 OH. All members will tend to follow suit. Members have the same general molecular formula. Number 3. Members have the same method of what? Preparation. Or members have similar. Let me use the word similar method. Not use same. Members have similar method of preparation. Similar method of what? Preparation. Or I can say members are prepared the same way. Members have the same method of preparation. They are prepared the same way. They are prepared the same way. They are prepared the same way. Methane, when prepared, there are so many preparations of methane. And the same way methane is prepared, ethane is also prepared by the same method. They are not that the same, they are just similar. Okay? If I prepare methane from decarboxylation, get it? You know what I mean, decarboxylation? What do you call this? CH3COOH. What do you call this? What do you call this? Ethanoic acid, have you? I want to prepare methane here. Okay? I will decarboxylate it. You know what decarboxylation? Removal of carbon in form of what? CO2. Remove CO2 from this. What is remaining? CH4. If I want to prepare ethane, will I decarboxylate the same reacting substance? Because if I decarboxylate this, it will still give me methane. So if I want to now prepare ethane, it will be similar, but this time I will now use maybe CH3, CH2, COOH. So that after the carboxylation, I will now have what? C2H6. So the method of preparation is what? Similar. I wouldn't want to use the word the same. Okay? Because if I use the same, that means the reagent will still be the same thing. But the method is still what? Similar to that method. So members have the same method of preparation. Number 4. Members have the same chemical property. Members have the same chemical property. Chemical properties. The same chemical properties. The same chemical properties. For example, who can tell me the chemical properties that this family alkane undergo? The chemical properties that they can undergo. Methane can undergo what? Combustion reaction, Abi. What is combustion reaction? That means both methane, ethane, propane, they will all react with atmospheric what? Oxygen. Or they will all burn in the presence of what? Oxygen. To give you what? What will it give you? Carbon dioxide and water. Let me show you that with chemistry of the reaction. Let's use this as example to that. Members have the same chemical. This is one chemical property they both share. CH4 gas plus O2 gas. What's going to come out here? Look at how to know what is going to come out. C from here will combine with O. Then I'm a balance equation. Watch qua. What will it give you here? CO2. You take a breather. What else? H from here again. We pick one O again. There is enough O to go around. Later you now balance it. Okay? Now remember that what is formed here is gas now. So make sure the matter states. If you write equation without state of matter, you've not written anything. So matter state of this is what? Gas. Plus what? H2O. What is the matter state of H2O there? It is not liquid. It is what? Gas. The water is released as steam. You know what is steam? That's vapor now. That's gas now. You will not see the water release during the reaction. So what you see? Condensed form, which the original state of that water there is what? Is steam, gaseous. Now let's see. Is the equation balanced? What do? You balance it. Carbon is balanced, so leave carbon alone. H is 4 here. H is 2 here. To balance it, you ask, what number will be here? If you times it with 2, you have 4. Is it 2? I'll add 2. I'll balance H. I'll come and balance O. I'll check how many O's here. We have 2 here and 2 here. How many O's do we have this side? What number will be here? If I times it with 2, I have 4. 2. So equation 9 is what? Balance. The same way ethane will also burn. C2H6 gas plus O2 gas. Here we have CO2 gas plus what? H2O gas. How do you balance this one? See, this is 2, Abby. Come here and put what? 2. Carbon is balanced. This is 6, Abby. What will you put here? You put 3. Then come and balance O later. To balance O, whenever you're balancing chemical equation, do you know why we are balancing the way the manner I'm doing so? Do you know what I'm doing? I'm looking at elements that appear very few in the reaction. Carbon is very few in the reaction. It's only here and here. So it is easy to balance fewer species in the chemical equation than ones that appear everywhere. See, the next element that does not appear everywhere is hydrogen. It's only here and here, so it is easy to balance. But if you want to start balancing your O first, you balance the equation to the lesson dismiss, because O appears almost everywhere except here. Is here, is here, is here. Please, that one that tend to appear too many in the reaction, please wait and balance it later or last. Like why I'm coming back to O to balance it last, because it is very difficult for you to start balancing an atom that appears to be what? Too many in a chemical reaction. But now that I've balanced the remaining species, I can come back for oxygen. Now coming back now, I'll say, okay, how many O? 7. Ask yourself, what number you will be here? If you times it by 2, you have 7. There is something. There's a number. You can use it in fraction. You can use it in fraction. You can even use it as 7 over 2. You can even use it as 7 over 2. You can use it at 3.5. 3.5 can go. Some of you will start wondering, which one is 3.5? You see what I'm going to do. See, watch before the magic will just pass you by. 3 points. Now listen. With 3 points, with 3.5 or 7 over 2, 3.5 times 2. It give you 7. But don't be so naive to leave your equation like this. Equation cannot be in fraction. So what you will do, close to that 3.5, you see 2. Use that 2 judiciously. Use that 2, multiply every reactant and product species with that 2. You are doing so to convert this to a whole number. Now, if you do so, I'm not yet done with the equation. So because of this 3.5, that's why I'm multiplying everything by 2. If 2 multiply this, it will double, Abby. Double it. Okay, opposite. 2C2H6 gas plus 2 times 3.5. It gives you 7O2 gas. 2 times this 2. It gives you 4CO2 gas. 2 times this 3. 6H2O gas. Is the equation balanced now? Yes. By force and by fire, it will balance. 2 times 2 is 4. Carbon is 4. 2 times 6 is 12. 6 times 2 is 12. It's balanced. Oh, 7 times 2 is 14. 4 times 2 is what? 8. 8 plus 6. Equation is what? Balance. Please balance this one for me. The last one, propane. Combustion of propane. Quickly. Okay. I'm blocking. Am I blocking? Okay. Why? Okay. You can as well use the general formula to balance all of them. For instance, I want to do the last one. Propane is what? C. Oh, let me do it there. Okay. Propane. C3H what? 8 plus. I can have 3 here. That is X. Abi? Plus. Y is what? 8 over what? 4. Bracket what? Close that. We have O2. Here. X is what? 3CO what? 2 plus Y is what again? 8 over 2 H2O. You can evaluate it and get your answer. So let's see. C3 H8 plus 3 plus this divided by this what? Is it 2? 2O2 equals to 3CO2 plus this is what? 4H2O. So finally I have C3H8 plus this place is what? Is it 5 or 6? O2 equals to 3CO2 plus 4H2 what? Oh, is it correct? So you can use this formula to balance all of them from 1 to 10. Just be plugging the values. Okay. Are you with me? No. Okay, let's look at the ones we just finished before. C2H6. Watch this one. We've done it before. Plus O2 CO2 plus what? H2O. Okay. I want to balance it from that general formula. Okay. So let the X for ethane be 2, Y 6 plus 2 here plus what's Y again? 6 over 4 O2 equals to 2 up here CO2 plus what will be here? 6 over 2 H2O. Let's go. C2H6 plus 2 plus 6 divided by 4 is what? 104. Which is 1.5. 1.5 here. 1.5 bracket close. O2. What here? 2 CO2 plus 3 H2O. I'm going to go now. C2 H6 plus 2 plus 1.5. 3.5 O2 equals to 2 CO2 plus what? 3 H2O. Can I keep it like this? Because of 3.5. What do? I multiply by 2. So now I have 2C2H6 plus what? 7O2 equals to what? 2CO2 plus what? 3H2O. Is that clear? Is it 6? Okay, I'm multiplying. Okay, I didn't even remember I'm multiplying. 6 what? H2O. We've done this before now, Abi. Just like I want to use this to balance it. Please copy this. Copy this. Make sure you use this to balance or unbalance or combustion reactions of methane. You can use this to balance it. That's general formula of combustion. Number 5. But I'll wait for you. I'll wait. Yes. Is it? It's only for every hydrocarbon. Every hydrocarbon. In carbon. So far no hydrocarbon. Alkanes. They can balance it. Okay. Yes. Number 5. Number 5. Members shows variation. Members shows variation. Members shows variation. 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 in physical properties. In what? Physical properties. Variation in what? Physical properties. Example. Alkanes from C1 on the board. Alkanes from C1 to C4. Alkanes from C1 to C4 are gases. C1 to C4 are gases at ordinary room temperature and pressure. Are gases at ordinary room temperature and pressure. C1 to C4 are gases. You know what is C1 to C4? That's methane, ethane, propane, and butane. These are gas. Comma. C5 to C17. C5 to C17 are liquids. That include my kerosene, my diesel, my petrol. C5 to C17 are liquids at ordinary room temperature and pressure. At ordinary room temperature and pressure. At ordinary room temperature and pressure. C5 to C17. While higher members are solid. Why higher members are what? Solid. Why higher members are solid. Full stop. So I think in all of this we say members have the same thing, have this thing similar. I think the one that is not similar here is physical states. They are not of the same physical states. You cannot watch the first 10 members of alkane now from methane to decane and say they are the same physical state. No, now. As the number of carbon atoms is increasing or relative molecular mass is increasing, okay, matter states appears to what? To change. So you change it from gas to liquid to what? Solid. So they don't have this the same. These are one property that is not the same. Another property that is not the same again is what? Molecular formula. Another property that is not the same again is what? Is molecular mass. But some other things like chemical properties, way of preparing, even functional group are similar. That's going to be the last property now. Number 6. Members have the same functional group. Members have the same functional group. Members have the same what? Functional. The same functional what? Group. Full stop. Subheading. Functional group. Functional group. Functional group. In organic chemistry, right? In organic chemistry, functional group is defined as a substituent. Is defined as a substituent. Or moiety. Moiety is a problem. Let me spell it. You can spell substituent, Abi. Or moiety. Moiety. Substituent. Since substituent has S, let's put this one to have also S. Or moieties. Substituents or what? Moieties. Of moieties. In a molecule of that compound. In a molecule of that compound. in a molecule of that compound, which determines the main chemical property, the main chemical property of the compound, or it can also be defined as an atom, or group of atom, or chemical bond, common to a particular homologous series, which determine the chemical property of the series, or it can also be defined as a reactive group. Reactive group of a molecule. Reactive group of a what? Molecule. Full stop. Paragraph. The following are examples, common examples. Please put common. The following are common examples. Of functional group. Common examples of functional groups. They are number one. They are number one. How do you pronounce this? Carbonyls. How do you write the structure of carbonyls? Do you know what is carbonyls? Whenever carbon form bond with oxygen, a bond between carbon and oxygen is called what? Carbonyl. So how will I write it now? Bracket what? C O. I've not finished, because I'll still give carbon how many bonds? 4. So how many bonds is remaining to be complete? 2. Oxygen has how many bonds? I think that's enough for oxygen, isn't it? So carbon will have 1 and what? 2. This is the structure for carbonyls. Either here, carbonyls. Either here. Number 2. Hydroxyls. Hydrogeny oxyls. Is it? Okay. Sorry. Hydroxyls. What is the chemical formula for this? Is what? What? O. How are you writing it? You know it should be O. Don't say OH. Bond. You must give oxygen how many bond? 2. Hydrogen how many bond? 1. So H should be here. This is a symbol for hydroxyl. Number 3. Number 3. Amines. 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 How do you write amines? N H and what? H. Amines. Number 4. Amides. How do you write that one? CONH2. Okay. 5. Cyanides. Cyanides. How did that one go? C triple. You know why you're giving triple bond to N? That's the valency. Make sure this one is complete as well. ETC. Okay. Let's look at some organic compound. Right. Some organic compound weights. Organic compound with carbonyl functional group. Carbonyl functional group. Organic compound with carbonyl functional group. Organic compounds with carbonyl functional group. Yes. Number 1. Who can tell me? Organic compound with, somebody mentioned alkanals. 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 Alkanal is carbonyl. But the carbonyl linked to hydrogen atom. A carbonyl with hydrogen atom in it is called what? Alkanal. Are you with me? Are you with me now? I said, if you should write it down now so you don't forget it. A carbonyl linked to hydrogen atom. A carbonyl linked to hydrogen atom is a functional group of alkanals. Is a functional group of what? Alkanals. Whenever you see a carbonyl linked to hydrogen, example, now let's see how alkanals functional group looks like. See, this is a carbonyl. But once it linked to what? Hydrogen. It is now what? Alkanals. Are you with me? A carbonyl is carbon-oxygen bond. If you link to hydrogen, that is what? Alkanal functional what? Group. It's very simple now. For example, if I have this carbonyl now linked to C that has 4 bonds. 1, 2, 3, 4. I have H, and what? H. Are you seeing this now? Now, make sure if you're naming this compound, the carbonic compound must be carbon 1. So which is carbon 1 here? This. Which is carbon 2 here? This. How many carbon are there in this chain? 2. Whenever you see an organic compound with 2 carbon, it must be what? 8. 8 means 2 carbon. So that means that this 8 will now end with this name. So it will now be what? Having CHO as functional group. This will now end at what? Ethanol. Their suffix is what? Anals. Their ending, anals. So open all the 3 in this chain. What name will it be? Propanol. Open all the 4 chain. What name will it be? Butanol. But what ensures that this particular organic compound is reactive? The reactive group of this compound is the functional what? Group. If the compound were to undergo oxidation, the carbon that will undergo oxidation in this compound is the carbon 1. That's why it is called reactive what? Group of a compound. Okay, that is for that. There are so many organic compounds that has this carbonic group. 2 is what? Alkanone. Alkanone. Alkanones. Alkanone is just C. Alkanone is the original carbonyls. That's alkanose has only carbonyl with 2 open chains. It doesn't link to any atom or group of atom. It can only link to what? To what? To 2 side chains. Maybe R. This can link to what? R and what? R. Then if the R is CH3 and the R is CH3, add it to this one. What is the name of this? Let's say it is not like this. It is now what? Propanone. It is prop, it's 3 now, isn't it? So it is now going to end in their what? In their suffix, which is what? O-N-E. So this is what? Propan what? Propanone. Or if you want to state the position of that functional group, you could have called this what? Propanone. Is that clear? What is not clear again? It should be clear. It should be clear. I say that the carbonyl linking to atom of hydrogen, whenever a carbonyl link to hydrogen atom, that is the functional group of alkanals. This is where lines of carbohydrates belongs, like glucose is alkanal. The functional group of glucose, you see that the first carbon atom of in glucose is what? CH what? O. That shows that that organic compound belongs to which functional group there? Alkanal. The glucose for reducing sugar, for example, is because of what? CH what? O. The organic compound with this one is not reducing sugar because their functional group cannot reduce phenylalanine or any other mild oxidizing what? Agents. That's what I say. The reactive group is the functional group, the reactive group in a molecule. No other group here will react except the what? Functional group attached. This open chain you see here is giving room for carbon chain to link. Simple and short. Okay, look at another one before I explain further. Let's look at another organic compound with carbonyls. Which organic compound has carbonyls? We mentioned alkanones. What about carboxylic acid? Carboxylic acid, which we call alkanoic what? Acid. Alkanoic acid also has carbonyl, but in the own case of carbonyl, the carbonyl link directly to what? OH. Whenever a carbonyl link to OH group, that is COOH. That is the functional group of what? Carboxylic or alkanoic what? Acid. Example, if this place is open to, let's say C2H5, then this, and this. Which name is given to this carboxylic acid? How many carbon atoms are there? 3. 1, 2, 3. So whenever you see 3, it is what? Propan. Then put the last ending there, which is what? Oic. What is this? Propanoic. The suffix or ending of alkanoic acid is what? OIC. Don't put that for the fact you have seen COOH. This is propanoic what? Acid. Are you following? is okay. Is this formula correct for ethanol? There are some people that will just be writing rubbish. We are just here explaining that alkanals are COO. Somebody is giving me C2H3OH. Is this an alkanal? Is there an alkanal? OH, what is that? That should be alcohol. But that's not even correct for alcohol. It's not correct for alcohol now. I don't know where the person get the formula from. If you want to do that, it could have been C now. It should have been like this. So that the name is now methanol. Okay, if you want it to be C2, that means the number of hydrogen atoms should be complete now. If it is C2, that means it's going to be what? H5. Before now what? OH. So you can now call it what? Ethanol. Because all these things are derivables. They are derivative of CN, H2N plus 1 OH. The number of values will start from 1, 2, and so if you are changing this, you see how we are going to be changing it. Supposing I have N is 3. Anywhere I see N, I put 3. Like C3, H3 here, times 2, 6 plus this, 7, OH. What is this now? This becomes what? Propanol. Now, one thing you don't know is that in organic chemistry, this thing sound is a Greek word. The Greek word met, M-E-T-H, means 1 carbon atom. X means what? 2 carbon atom. Prop means what? 3 carbon atom. But means what? 4 carbon atom. Pent means what? 5 carbon atom. 6 carbon atom. That's hex, Abi. Hept, 7. Oct, 8. 9. 10. So, the only thing that you'll be changing is the suffix. Is the what? Suffix. The ending. Ending that you will change will depend on the functional group. Voilà. Suppose I have something like this. Watch this. 1, 2, 3. And I ask you to name this for me. What is the name? In this case, is propane. Component means is hydrogen. Propane. But the moment I put something like this here, the suffix will now change because of double bond. The double bond means in. The functional group here is in. So just change the in and put in. So this is what? Propene. Propene. In will not be there. Do you get the point? Do you get my point? Then if I eventually leave it this way it is, and maybe put OH here, what name will be this now? Is what? I have problem with this propanol. Do you know my problem with propanol? Means that the number, the OH can shift position. What if it's in the middle of the carbon atom? What will it be? Is it still going to be propanol? So the number is not fixed, isn't it? So you make sure that you state the position of the OH. Where is the OH located? Which carbon atom? 1. So that is propan 1 or. Because if I shift this OH here, that should give me what? Propan 2 or. If I shift it to this carbon atom, what will it still be? It will still be propan 1 or. Propan 3 or does not what? Exist. Because you must give the side chain, the substituent. Because I told this in the definition. So I told you that functional group are substituents. The OH is just a substituent or a moiety in a molecule that determine the chemical property of the compound. What determines the property of the compound now is the word OH. One of the properties now is solubility. Now the compound is soluble in water is because of the word OH, because that OH there is hydrogen bond. Chai. somebody is mad. Can somebody give me I will stop collecting this thing from you. You will not only get a good paper, you will not choose a funny paper like, oh, we pick it from the floor. Oh, you can get you see me. His day is big. He give me. Eh? How can somebody do a thing like this? And ask me to name it. Please, whoever that did this, I will assume it to be you. Stop collecting. It does not have name. Of eternal. None eternal ever now. It does now. Okay. C. What's this? C. 2. H. 1, 2, 3, 4. 4. O. That's the molecular formula. Exactly. Of eternal. What's some formula like this? I'm going to know eternal. What's some eternal? I'm going to know eternal. Imagine I want molecular formula of eternal. This is condensed formula. Molecular formula will be what? If you just like do it as if you are collecting like terms. Okay? C2H6O. O what? Just O. So it doesn't look like something else. Oh, that's the molecular formula. Okay, let's go to next one. Is that all? Can this be only collecting irrelevant information? Okay, this one is better somehow. Someone say whether this one does exist. Yes, this one can exist. This one can exist. Someone say, can this exist? Yes, it can exist. It can what? Exist. What is this? No, this one is not propanol again. So this one has bifunctional group. Over 2 functional group. OH and double bond. This is called propinol. Propene. Then put what? Or. Because it's an alkene. It is an alkenol. Listen to me. You know that alcohols, okay? If it's alkanol, that one is saturated. Single bond. But this we call alkanols. Can you get to alkenols? I guess we alkynols. If you have triple bond and OH, you become alkenols. Double bond with OH, you become what? Alkenol. Then alkanol. This is the one that is very common. But this is unstable. Or unstable. If you rearrange this thing now, in what is C. You want to say here? If you now, if you arrange a propinol, what will you get? What will you get? You get what? Propanol. I mean now, this is unstable. It's an unstable organic compound. Can you what cause both? But can I to what? Propanol. Did you get it now? So propinol and propanol, they are isogeny. Isomers. Yes. I cannot add what? One again. Okay, I will not add one. No, I don't need to add one there because the priority functional group there is the double bond. So you don't need to add it. Just name. Yes? When assigning locality, you start from here. It will be 1. But since they are bifunctional, position does not matter now. But it's, even if you want to put it, it should be what? 1. It will be 1. Closer to this, closer to this. This is where you start from. Okay. Now let's go to, is there only compound that have this carbonyl? Are there still more? Yes, there are still more. Number 4. Number 4, esters or alkanoids. 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 Are you there? Functional group. It's a carbonyl. Look at it. Esters. It's carbonyl. Can you see? But the carbonyl linked to oxygen. Whenever you see an organic compound that has carbonyl linked to oxygen, please, that is an what? An ester. I'll give you an example now. You have something like this, and then you have this having carbon here, and this having carbon here. Let's see, this carbon here is still length here, or this carbon here is much. This, okay, sorry, this is O, this O, linked to what? C. Watch this. Or rather, C, like this. What do you call this? No, now. No, now. In ester, in ester, in between, the functional group is at the middle. You have methyl here. You have alkyl here. Another one here. This is an alkyl now. Alkyl, alkyl. Name this alkyl. Starting from the alkyl that is positioned on the right hand side. The right hand is this one, Avi. So this is methyl. You say methyl. You take a breather. You go back. You count this carbon what? 1. Count this one what? 2. What is 2? 2 is what? Ethane. The what is the ending that will end all esters? All esters will end what? OAT. Now put what? OAT. That is the name of this. Methyl ethanoids. I'll say it again. But before you understand this, let me help you. Okay, watch. Okay. The general formula of acanoic acid is what? Acanoic acid. CnH2n plus 1 COOH. What about alcohol? CnH2n plus 1 OH. Which reaction is this? Then you react this with this. What type of reaction is this? It is what? It is esterification. What is esterification reaction? Ester plus what and again? What is esterification? A reaction between an acanoic acid with alcohol. It forms ester. Look at how the esters are formed. Next time, the question. Elegant. When you make acid, when you go for H plus, when you make a base, when you go for OH. Watch here now. K positive now will now be what? CN H2N plus 1 COO. There is no H again. Now add this one. CN H2N plus what? 1 plus what? H2O. If for example, that this N here is 2. Is 2. Is what? Is 2. And this N here, let me say, this N here is 1. And this N here is 2. Well, let's change it. Let's change it. Anywhere we see this man, we say 1. Here. I've got 3. Now watch a quaho, get a joke out to the worries. Let's take a munkaketa. 1 times 2, 2 plus 1, 3, COOH plus. Anywhere I see this man, I put what? 2. Put 2 here. Times it with 2. What do you have here? 4. 4 plus 1, 5. 5 up here? OH. Well, let me react 2 of them. What punya? I was nam kanda chendede. Wakaide, ginga puteba. CH3, COO, C2, H5 plus H2O. Esterification. If you have ethanol, can say that we are. When you are beginning ethanol, go able to it's in ammonia. Name from alcohol. Name a structure. Which one is the alcohol in this structure? This one. Name the alcohol first. Alcohol, the back beginning ethyl. Then alcoholic acid is going backward. Is what? Is what now? It's still et up here, but it will not end in what? In what? No it. So that's the name. Ethyl ethanoate. Alkaline. See, this is the no. Do you know if I hydrolyze this man? If I add water, the reaction can still go back and forth. Forward reaction is called what? It's called what? It's called what? It's called what? Condensation or esterification. What will backward reaction be called? What is this? Hydrolysis. What a body? What a body? This and this. So, what is the functional group of this ester? Name me about COO. Carbonyl linked to oxygen atom. Oh, their ending is what? Is what? Oh, it's. Yata was. Show, please, who is giving the priority functional group when there is 2 functional? Okay. Now I know. Hey, this is a very good question. Not when somebody will ask. This is a question that will all benefit all of us. So, say, who is giving the priority functional group when there are 2 carbonyl groups in a compound? Good question. I like the question. Okay, let me give you an example. But the writer of this question, you are very fast. You are too fast. Faster than your shadow. C. Watch this. C. I have this. Are you there? And I also have this. How many functional groups are there in this molecule now? There are 2. So the person now asks me, which one we giving first priority? The priority, other priority. The priority should be given to the one that is carbonyl. Which functional group is carbonyl there? C. That's not C. The carbonyl, the one you give is this one. C-double-bond-O. Carbonyl, before you get to follow on. So, you want to get a carbonyl 1, 2, and what? 3. You know that this is supposed to be alcohol, Abby. But for the fact that no go with another functional group that is higher than OH, he will answer his prefix name. Prefix. Okay, my prefix. And for Gaza, Mobu no onye no chiria na compound. Gabozigini hydroxyl. But everybody see this is a mobu no so in a structure. Assuming it appears that it's only one in the structure. You see is suffix, which is what? Or. But you cannot answer all here. You guys say about kita on the position 2. You kita 2 what? Hydroxyl. 1, 2, 3 is what? Propan. COOH is what? OIC. Propanoic what? Acid. That is the name. But it will not appear like this without this OH. What? C. Here, OH. 1, 2, 3, 4, 5, 6. If it appear here, it will not answer this hydroxyl again, but it will answer is what? Suffix name, which now is going to be called here propanol. Same thing also will happen to if it is changed to NH2. Whenever you see a carbonyl group with any other functional group, once it is non-carbonyl, this is non-carbonyl, carbonyl will take priority. So if carbonyl take priority, this man is called amino. 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 Carbonyl 2. Here kita 2 aminopropanoic acid. But assuming now not something on there, it becomes propylamine. Okay. Those are the backs. Is it not bold enough? It's not bold enough. It's bold though. Let me stand from that standpoint. Is it not bold? Sit down. You don't need to. No, look at this thing. Look at. It's too bold, Abby. It's too bold. You're not whining. It's bold, Abby. You see, majority carry the vote. Say it's bold. Shut up. Don't know anything. Blind Bartimaeus. Then you look at what they're doing. You come and say it's not bold. Okay. Bold that is so I'll broaden it. I'll broaden it. Again. I hope all is well with you. I hope it's visible now. Is it visible? Okay. The functional group of the alkanes is what? Look at me. The functional group of alkanes is what? Alkanes is what? Nothing like single bond. You will say that it is what? Carbon. What? Carbon. What is this? Single bond. If you say single bond, it's wrong. How do you draw the structure of that carbon-carbon single bond? C. Abi? Alkanes have a prefix. Have a prefix. Prefix. Prefix is what? Nil. Suffix is what? Is what? A. Example. Methane. If you have something like alkenes, what is the functional group of alkenes? Carbon what? Carbon what? Double what? Bond. How do you draw the structure of carbon-carbon bond? C bond, Abi? Does it have any prefix? Nil. Let me use the word nil so it doesn't look like nil. Does it have any suffix? Yes. Which is what? In. Kappa is what? 18. Functional group of alkyne is what? Carbon, triple, have you? Triple what? Bond. C bond. No prefix. Any suffix? Yes. Which is what? Ine. Example is what? Ethyne. 4. Alkyl. Halides. What is the functional group of alkyl halides? We have it as what? Halo what? Group. Halo group. Here the symbol for the structure of halo group is what? What is this? X. I think I told you what X can be. X can be what? Can be what? F, Cl, Br, and what? I. What is the prefix? Have a prefix. Which is what? Halo. Any suffix? Nil. I'll give you an example now. What do you call this? What do you call this? Dichloroethane. How are you? Dichloroethane. So you see that the chloro is the first prefix. There is no suffix. Their suffix is "ane," so it's not their own. So they have halo beginning, no ending. So example, I will use something like what? Chloro what? Ethane. Just how this is. This is the prefix, no suffix. If I have something like alkanals, functional group is aldehyde group. Aldehyde. What is aldehyde? Then you have COH. I think I told you about this. CHO. What is the prefix? Do you have prefix? No prefix. Any suffix? What is suffix? Okay? Anana. Example is what? Is what? Ethanol. M6. Alkanones. Kitonu. Group. Kitonu. Neo. Onu. Propanone. Okay. Are we there? Let me check. Sit. Take here is your palo. You're not writing. You're not seeing up to now. The lesson. Okay. Okay, somebody give us the structure to name. Can you see that structure there? Can you name it? What name? What name? I'm waiting now. What name? What name? Yes. Okay. Okay. Yes. The name? Hexane. Huh? It's a Syria. Okay. The name? Yes. 2,2-dimethyl butane. Okay. The name is from the long chain. Look to see where the chain where appears to be longer in this chain. Is it 1, 2, 3? Or is it 1, 2, 3, 4? Or 1, 2, 3, 4? 1, 2, 3, 4. It's still long. Let me from here. 1, 2. This carbon is what? 3. And also what? 4. So the long chain is boots. That means it has methyl group at position what? 2. Can you see now? So this is what? This man is what? 2, 2 again. There are 2 in number. So dimethyl. Since the long chain is 4, end it with what? Butane. That's correct. Can I clean now? Okay. Yes. Pass it. Throw it. Just. We have named this one before now. We have. We have named this one before. Okay, what was the name of this? We've named this before now. Which is? Why is acanone not a carbonyl? Please, acanone is carbonyl. Acanone is carbonyl. No one can take it out from them. Acanone is carbonyl. Carbonyl means carbon. Acanone. Look at acanone here now. Where is acanone? Acanone, no, 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 no. See it here now. It's carbonyl. Carbonyl is any functional group with CO in it is carbonyl. Any organic compound we see, not all of them has CO. You can't see CO in alkynes. You can't see it in alcohol. But you see it common. Many organic compounds has carbonic acid, esters, amides, not amines. They are all carbonyl. Okay, so this is what? 2-hydroxypropanoic acid. It has been named before. Okay, subheading. Naming inorganic compound. Naming. Uncle, please name this compound. I will name it. Naming. Is it here? Can someone help us name the one on the board? Yes. Okay. Yes. Is it correct? The longest chain is 2, 3, 4, 5. 2. Come on here is 3. This is a side chain. So it is at which position here? 3. So that's correct. Naming inorganic compound. You take here? Naming. 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 You take where? Naming. Organic compounds are named. Please make sure you're writing. Organic compounds are named. Organic compounds are named. Are named based on IUPAC. Are named based on IUPAC. Look at it. Look at it. IUPAC. Based on IUPAC. You know the meaning of IUPAC? I'm going to open bracket. Let's try the meaning. International. International Union. International Union of pure and applied. Pure and applied chemistry. We'll close that brackets and write rules. Rule. Take what S na rule. Organic compounds are named based on IUPAC rules. IUPAC rules. Full stop. Paragraph. The following are set rules. The following are set rules. The following are set, S-E-T, are set rules in naming hydrocarbons. In naming hydrocarbons. In naming hydrocarbons. In naming hydrocarbons. That is organic compounds. That is organic compounds whose constituent elements. That is organic compounds whose constituent elements. Whose constituent elements are carbon and hydrogen only. Are carbon and hydrogen only. Are carbon and what? Hydrogen what? Only. Full stop. The rules are as follows. The rules are as follows. Number 1. The rules are as follows. The rules are as follows. Number 1. Name the longest chain. Name the longest chain. Name the longest chain and assign prefix. And assign prefix. And assign prefix as follows. And assign. I'm not finished all of them. and assign prefix. And assign prefix as follows. Well, assign. All right. Number of carbon atom, and here you write prefix. If you see one carbon atom, what prefix will you assign? Is what? Met. If you see 2, what prefix will you assign? Et. If you see 3, what prefix will you assign? Prop. If you see 4, what will you assign? Boots. If you see 5, what will you assign? Pens. But please run it down to 10. Run down to 10. Run down to 10. Okay. I would like to give an example of that. Example. How do you name this? Example. 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 Okay. How do you name this? How do you name this? Yes. Name is what? Correct. Name is Nicholas No 14. This is what? Hexane. The rule says the longest chain. The longest chain. Longest chain is not 1, 2, 3, 4, but 1, 2, 3, 4, 5, and what? 6. If what see I now if you know hexane. Are you there? Hexane. Jump. So the name is what? Hexane. Hexane. Not 1, 4 as you think. Dimethyl butane. If you have 1, 4 dimethyl butane na option A. Fusin kana option D. If you think option D, that is number 1 rule. If you want to name, check to see where the longest chain, the length of the carbon chain. It mustn't be straight. Find out the longest chain. And if you find out now that I've seen that the longest chain here is 6, Abi, carbon is 6 at long run, then you will now assign what now? Hex. Okay? Why are you ending with A? Because every carbon atom there are what? Single bond. That's when you end in what? A. Is that clear? Rule number 2. Number 2. Number 2. If a side chain occurs, if a side chain occurs, comma, number the carbon on the long chain, Number the carbon in the long chain. If a side chain occurs, comma, number the carbon in the long chain. 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 To give the locants or the side chain. To give the locants. To give the locants on the board. To give the locants. To give the locants or side chain. Or side chain. The locant or side chain. Lowest possible number. Lowest possible number. Lowest possible what? Number. Lowest possible what? Number. Full stop. Example. 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 How will you name this on the board? How will you name this on the board? Is it not 4? Is it 4? I think you know it cannot be 4. What the rule says that if you number, if I both best thing to do, number both sides, and then choose which side is lower. For me, if I want to name a structure like this, I'll number 1, 2, 3, 4, 5, 6. I'll number again. 1, 2, 3, 4, 5, what? 6. And then I will not choose the locant where it's located. Which number is lowest here? Is it 4 or 3? I'll choose 3. I'll name this first. The position must be stated. So it is a which position here? 3. I'll now put what? Methyl. What is the long chain? How many carbon in the long chain? 6. And 6 is what? Hex. Hex guinea A. So the answer is 3 methyl hexane. I can also skeletalize the structure. Do you know what I mean, skeletalize? I can also omit the carbon, omit hydrogen. I have a structure like this. And then this. This, they are the same. The joints. Every joint you see here is carbon. 1, 2, 3, 4, 5, 6. The side chain 1, 2, 3. This is what? This is what? The what? Methyl. Or I can write it this way. I can decide to do this structure CH3, CH2, CH3, CH2 brackets 2 and the what? CH3. Which structure is this? Which type of structural formula is this? This is what? This is structural formula, B. What is this? Skeletal. Skeletal. Skeletal is if you omit some important atoms like carbon, hydrogen, it becomes skeletal. Which structure is this? Condense. Condense is if you collapse some bond and bring the atom more closer to each other. This is condensed structure for this compound. Actual structure and what? Skeletal structure. Are you there? What do you call this? Condensed, actual, skeletal. Okay. One more example before I go to the third rule. The third rule. Okay. Now see this. Okay. Okay. Name this compound. Name this. What name is what? See, if you are given such structure, please try to convert a structure from condensed to actual. It's condensed. It's small. Well, let me now broaden the structure. This C will actually have what? 1, 2, 3. H. Like this. This C is what? 1, 2, 3. H6. 1, 2, 3, 4, 5, 6. And then this C is what? H with 1, 2, 1, 2 what? 3. H7. 1, 2, 3, 4, 5, 6, 7. Okay? This C is what? 1, 2, 1, 2, 3, 4, 5. That's the structure. You must make it very, very actual, very, very open for it to be very easy. Check where carbon is. Is it 1, 2, 3, 4, 5, 6, 7? Or 1, 2, 3, 4, 5, 6, 7, 8? This is not part of the chain again. This is a side chain. So check the location of this side chain. This side chain is 2. So that is 2 means ethyl. So check this carbon. This which side will give you lowest number. Is it 4 or 5? 4. Well, number both sides. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, what? 8. We are choosing what? 4. So that methyl, that ethyl is at position 4, Abi? That is 4 what? Ethyl. The longest chain is what? 8. And the last time we check, 8 is what? Octane. That structure there is 4-ethyl octane. Take it down, let's go to rule number 3. Rule number 3. Rule number 3. After rule number 3, we call it a day. Are we there? Are we there? Number 3. Number 3. If two or more side chains occur, 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 comma, number the carbon in the long chain, 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 to give the side chains lowest possible number. To give the side chains lowest possible number. Lowest possible number. Lowest possible number. Lowest possible number. And use. And use. And use. And use. Die. Di. Die. Comma. Try. Di. Comma. Try. Or tetra. Or tetra. Or tetra in the case of two. In the case of two, comma, 3, comma, 4. 4. Similar side chain. 4 similar words. Side word chain. Full stop. Example. Example. How do you name this? 1, 2, 3, 4, 5. Okay. How do you name this? How do you name this? Is it 244 trimethylpentane? Is 224? Why are we not going for 244? Because he watch out 244, 224. 244 is like 244. 224 is like what? 224. So which number is lower? So the correct answer is what? 1, 2, 3, 4, 5. Methyl is here. Methyl is here. So that carbon position is what? 2, 2, the last one is what? 4. Then tri. Then methyl. Then what? Pentane. Not 244. 2. Make sure whenever you see multiple numbers, separate with comma. Whenever you see number and alphabet, separate with what? Hyphen. The last rule, I will go. I cannot stop without this rule. The determinants. The last rule. What's wrong with you? I hope all is well with you. Okay. Okay. Should I? Should I? Continue. The last rule, number 5. Number 4. Number 4. It can be number 5 in your own. If two or more on similar side chain occur. If two or more on similar side chain occur. If two or more on similar side chain occur. If two or more on similar side chain occur, comma, number to give the side chains, 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 lowest, lowest, possible, lowest, possible, number, lowest, possible, number, and then name in alphabetical order. and then name in alphabetical order. And the name in alphabetical order, not number order. Name alphabetical order, not what? Number order. Example. 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 This rule is only for alkanes. You still have rule for alkanes. But not today. We're not going to be talking about that one today. 1, 2, 3, 4, 5. Someone help me with his name. Please read the rules once again, then answer the question. So you understand the rules. So you don't follow number order, but alphabetical word order. From what we have now, we look at this. We have two side chains here, Abi. They are not similar. Two side chains. 1, 2. Make sure you give the lowest number possible. If you follow here, you give this one lowest number. But you will not give this one lowest number. But if you follow here, you give this one lowest number, lowest number. All the side chains has lowest number, Abi. But don't say because 2 is before 3, and you now start naming 2-methyl. Alphabetically, E should come before what? M. So start with what? 3-ethyl. Then you go to what? 2-methyl. And then the long chain is what? Pentane. Does it follow? If you see a case like this, that's how we name it. Okay, that's how you name it. You don't use di or tri because the two side chains, they are not what? Similar. Make sure whenever you are separating a number and alphabet, you must separate with what? Hyphen. Don't say 3, ethyl. It gives. So what must separate a comma? In fact, you should write it down though, so you don't forget it. If I were you, stop writing. Please take it down because I want to drop mic and go. Notes, notes, MB, notes, MB, notes, MB. Right. A comma must separate 2 or more numbers. A comma must separate 2 or more numbers. 2 or more numbers. 2 or more numbers. 2 or more numbers. While hyphen separates a number, and alphabet. A number and what? Alphabet. That is why in this case, whenever you see a number, you see a hyphen will always exist in between number and alphabet. Abi? But in the case of 2,2,4 dimethyl, see those 2,2,4. See what is separating them in between is what? Commas. Commas. That is how it should be. That is why it should be. That is the rules. How you pack rules in naming organic compound. You can now continue writing. Any question, please? I think at this point, I have to call it. Any question? Any question? Any question? Any question?